Hello and welcome to BioCode. Hope you are doing well. The agenda of our lecture is docking a library of compounds using the molecular operating environment software. For this lecture, I have selected the ABL kinase receptor and 30 compounds that I have downloaded from the Cambridge database. Those 30 compounds will be docked against the active site of the ABL kinase. So let's get started with our lecture. So as usual, we will browse the receptor molecule first. So go to the file and open. Now browse to the folder where you have saved your compounds and your receptor. So I will browse here. So 1IEP in the PDP format is our receptor. So I'll click on OK and then select the biomolecule assembly in the symmetry drop down list and then click OK. So now as you can see, the receptor molecule, the ABL kinase, is loaded to the MOE. Click on the sequence in the top left corner. Click on the ligand and the water molecules. So these two chains, the extra ligand that is attached to a receptor and the water molecules, will be removed first. So click on delete. Here you can see confirm deletion of two chains, 104 residues and 140 atoms. So click on OK. So now you can see the extra chain and the ligand has been removed. So now go to the bottom left and click on ribbons. So I will change that to ribbon display and close the atoms that are visible there. So here you can see now this is our ABL kinase receptor. Before we continue with docking the library of compounds, first we will do the quick prep. What actually the quick prep will do is it will fix the protonation, the bond angles, the bond lengths and other inaccuracies in the structure. So click on OK and click yes. So here the quick preparation has begun. Here you can see correcting one termini issue. It's going on. It will take a moment, and here you can observe that what corrections the MOE are making in the structure. The next is you can use multiple other servers and softwares to identify the active site of the receptor molecule. Once you have identified these the active site residues, you can click on the sequence and select. If these are the multiple residues, for example T, and then click on control, you can select M and V and so on L. But if there are the next 5 residues are in the active site, then you click on Shift N. So this is how it will be selected and it will be much easier. Here, so this is how you select the residues, the active site residue. But if you do not know about the active site residues, you can use the MOE site finder function. So go to the compute and the drop down list, go to the site finder, and here in the atoms display select the receptor. Here the PDB ID is 1IEP. So I will select 1IEP and click on apply. So here you can see the active site residues have been predicted by the site finder function of the molecular operating environment. So I will mark the select residues in SE, in sequence editor. So click on close and close the window. So now you can see the selection has been made. These are the active site residues where the library of 30 compounds will be screened. If you click on the sequence, you can see the residues have been selected. Now close the sequence editor and go to compute. In compute you will find the dock option. In dock, here you can see the receptor, whether it's an MOE format on the MDP file. So leave that to MOE. The receptor atom, here you have to select your receptor molecule. So our receptor is 1IEP, so I will click on that, and then the site. This refers to the active site residues. So here I will click the selected residues, as the active site residues predicted by the site finder function are selected. So I will click on the selected residues here, and in the ligand I will click on the so in MOE here we will be uploading our file that is in MDB format. So I'll click on that, and an option will be given from where I can browse the database. So click on that and go to desktop and browse your file. So here you can see library of 30 compounds. So click on OK, and now you can see the 30 molecules have been uploaded. So here you can see the 30 molecules have been uploaded. Here you can go to the triangle matcher. So by default, leave that by default unless you are doing a pharmacophore query that we will be discussing on in our coming lectures. In refinement, you can either do the rigid receptor docking and the induced docking. The rigid receptor docking is actually that the receptor will be in a fixed position and the ligand position will be changing and the active site residues. And when you do the induced docking, here you can see that both the ligand and the receptor molecule both will be moving. So here I will do the rigid receptor docking so that it takes less time. And then the scoring will be London DG and GB6 WSA DG. Here the poses, I will reduce the poses to 5 poses, and I will leave that default. Here you can save wherever you want. So I will provide the location of the output file. Okay, so here I will do the doc 30 compounds and click on OK. Okay, so now after running it will start docking the library of compounds. But before I will tell you something when you are arranging the database of compound. So I will close that for now, and we will browse the 30 compounds that I have selected for screening. Here, click on the 30 compounds. Here in this list you can see the 30 compounds have been selected. So these are the 30 compounds that have been selected. Here you can see this is the structure, this is the ID, and this is the supplier, the Cambridge database from which I have taken these compounds. This AAC means the hydrogen bond acceptor, this is the hydrogen bond donor, this is the molecular weight, and this is the log P value. So what are these values? By default you will not see these values, so let me delete it for now. You might have some other description here with in these column, so you have to remove this first by clicking on the column head and then delete and click OK. Okay, so let me tell you that how we select which molecules would be docked, that would be prepared. So we will follow the Lipinski rule of 5. What the Lipinski rule of 5 states, it is an orally active drug has no more than one violation. It must not violate any of the Lipinski rule of 5 properties. So one of that is the hydrogen bond donor property will be no more than 5, and the hydrogen bond acceptor property will be no more than 10, and the molecular weight will be no more than 500 daltons, and the octanol water partition coefficient, that is the log P, it will not exceed 5. So we will have to look for these 5 properties in each of the compound. So here we will go back and then go to the compute and then the descriptor. In the descriptor you go to the calculate. So we will be loading these 4 properties of the Lipinski rule of 5. If these are not by default, then you can click on the compute and then the descriptors and calculate. So here I will write acceptor Here you can see number of hydrogen bond acceptors. So I need this property, I will need to check this property, so I will click OK. So in this column you can see the hydrogen bond acceptor properties appear. Now again to the descriptor and calculate. I will now look for the hydrogen bond donor property. Okay, so here you can see the hydrogen bond donor properties. Then the next property is molecular weight. So I will search for molecular weight. So here you can see this is the molecular weight. Now again the fourth property of the Lipinski rule apply. That is log P. So here you can see log octanol water partition coefficient. Okay, so I will click on that. So now you can see here. Now how do we find which atoms do not follow these 5 rules? And so first I will go to the acceptor, click on the column head and go to sort and descending order. So what were the property for the acceptor? So here you can see the hydrogen bond acceptor must not exceed 10, and here you can see the score is okay. So here the score is, you can see the score is 6, and then it is arranged in the descending order. So when you go down, the acceptor number will decrease. So if in case, just like in this case, the value is 6 and it's acceptable, it's less than 10. But if any compound here would have a value greater than 10, so you have just to select, for example, 1, 2 and 3. These have the acceptor hydrogen bond acceptor number greater than 10. So click on that file. Okay, sorry. So click on that and delete. So here you can see left click and then delete. So right now this is okay, it's less than 10, so I do not need to delete this. Next you have to do is same, arrange that in the descending order whether it satisfies the hydrogen bond donor property. So here you can see the hydrogen bond property 5 hydrogen, it must be less than 5. So here you can see all of the compounds have less than 5 hydrogen bond donor. You can see in same way, if it's greater than 5, then you have to select those molecules and then left click and delete. But for now these are fine, so I don't need to delete it. The next is go to the molecular weight, sorry, not delete, sort and then in descending order. So now here you can see the molecular weight is 486. This is less than 500. If in any case it is above 500, then you have to delete all those compounds as well. And then the log P value.